Hello, good morning, good afternoon, or good evening, wherever you might be. My name is Chris, and this is an AWS webinar about faster deployments with CDK pipelines. Recently, the AWS Cloud Development Kit team released a new feature of the CDK called CDK Pipelines. This allows developers to programmatically generate application deployment pipelines with the CDK, allowing them to deploy code even faster than before. Today I'm joined by two of my friends from that team who are going to jump into some of the reasons why we developed CDK pipelines, as well as a demo around building our first CI/CD pipeline with CDK pipelines. Before we begin, just a quick agenda for today. I'll start off with some very brief introductions of myself and the folks that are joining me on this webinar. And then for anyone that is joining this webinar that is unfamiliar with the CDK, I'd like to give you a very brief 30,000-foot overview of what the CDK is and what it can do for you as a developer. And then we'll hand it off to Eric, who will give us a presentation on infrastructure as code with CI/CD principles, as well as some of the reasons and design decisions we made around developing CDK pipelines and some of the opinions we took around that. And then finally, we'll hand it off to Rico, who is going to build our first CI/CD pipeline with the CDK and even show some features of CDK pipelines that you may not realize are part of it. So to give you a brief introduction to myself, my name is Chris. I am a developer advocate at AWS, and I am focused on developer user experience and tooling. And I'm also joined by Eric Beard, who is a software development manager specifically for CDK, as well as Rico Hybers, who is a senior software development engineer for the CDK. Now, with that said, you might be joining this webinar wondering what the CDK is. And while the CDK pipelines is a pretty complex topic, I'd still like to set a little bit of context for anyone joining us who may be early on in their AWS CDK experience. So to put it simply, what the CDK allows you to do is to compose and model application infrastructure in AWS in the same programming languages and in the same models that you're developing your application code. In the past, when developers have had to either request infrastructure for their application code or build out infrastructure for their applications, typically that has required a different mental model than how they're writing their application code. So when we first set off to develop the CDK, we wanted developers to be able to write their infrastructure code in the same way that they're writing their application code. So if they were writing their application code in Python, we wanted developers to be able to model their infrastructure in those same languages and take all the benefits from those programming languages and use it with their infrastructure at the same time. So when we think about what the AWS CDK is, I like to divide it into three main buckets. We have the core framework, we have the AWS Construct Library, and then we have the AWS CDK CLI. So when you're developing your first CDK application, essentially what the core framework consists of is many constructs. You have an application that is composed of many constructs. You have stacks within your applications. And then finally, you have resources that map to AWS services such as S3, Lambda, EC2, etc., etc. And then also, when we are developing the CDK, we have this idea of constructs. We have level 1 constructs, level 2, and level 3. And I'll start at the highest level first. So a level 3 construct is essentially an application or a pattern of application infrastructure inside of AWS that is composed of one or many AWS resources. The CDK pipeline, as we'll jump into this later, is a perfect example of a level 3 construct. It takes an opinionated approach about how to deploy many pieces of AWS infrastructure and deploys it for you. We then have level 2 constructs, which are intent-based constructs based around AWS services that it will make it easier for a developer to move faster. And then finally, we have this idea of the level 1 construct, which is a one-to-one mapping of an AWS resource to its CloudFormation resource. So that's the core framework. Moving into that, we have the AWS Construct Library. So when you're developing your AWS application, you might need to use a service from one part of our service offering to another one. Thankfully, with the AWS CDK, we offer, like I said, a one-to-one mapping of all of these services and offer that as part of the AWS Construct Library. And these are all available as packages and modules in the languages that we support. So if you were using S3 to create a brand new bucket inside of your application, what the AWS Construct Library would represent is S3 as a package that you would install with a package manager like pip. And then finally, you have the AWS CDK CLI, and this is your gateway into the Cloud Development Kit. This does things like synthesize your application, which takes it from your application or your CDK code and turns it into a CloudFormation template. You have the ability to run commands like CDK diff, which shows you the resources that will be created. And you also can spin up your infrastructure, you can spin down your infrastructure, among many other things. To show you what that looks like in real life, this is a great example of a URL shortener application infrastructure stack built directly with the AWS CDK. You'll notice immediately that this is written in TypeScript, and it allows you to use the same paradigms in TypeScript for your application code like you would for your infrastructure. As you can see here, we're declaring some constants that allow us to declare our VPC. We're creating new ECS clusters. We're even creating a new Fargate service in this application as well. And you'll see that all of our configuration are just parameters that we're passing to our code. So this is really great because it allows us to, again, keep that same mental model about how we're developing code, just like our infrastructure. We've also made sure that when you're using it, when you're using the AWS CDK inside of an IDE, that you're getting all that great tool support. So you're getting things like autocomplete and inline documentation that allow you to see the context of a specific method or a specific variable that you're calling. And this all allows you to do this in the same way that you've done this before. Today, we have support for many languages. We have support for Python. We have support for JavaScript and TypeScript. We also have support for Java and C#. And eventually, we'll have support for Golang as well. Now, with that said, I'd like to hand it off to Eric, who will now dive into infrastructure as code with CI/CD principles and talk about some of the decisions we made when developing CDK pipelines. Thank you so much.
Thanks, Christian. Hello, everybody. Last month, we were super excited to release the preview of CDK Pipelines, which is a high-level construct that allows you to quickly define a complete delivery pipeline for your application using the CDK. I'd like to spend a few minutes talking about the motivation behind the project and about some of the design decisions that we made. In the past, I worked as a solutions architect. So I was helping AWS partners and customers to design their systems to run on the AWS cloud. And we were always preaching best practices about automating everything, right? Automating all of your infrastructure, automating your builds and your delivery, not just your application code, but also your infrastructure code. And it generally wasn't too hard to convince people of the benefits of having this complete automation and setting up an automated CI/CD workflow. But the next question, obviously, that we always got was, okay, so how do I do it? And that's where things got complicated. Obviously, we're working on top of some great building blocks here. We have, CloudFormation, we have the Code Suite tools, we have CodePipeline, Code Build, and Code Deploy. But it generally was a fairly involved project to get a complete CI/CD pipeline working, especially if you started talking about wanting to deploy cross-region and cross-account. So we took these building blocks. We have CloudFormation, and so we built CDK. That was the first thing, which was let's make CloudFormation easier to work with. Let's make it so that you can work in the language that you use every day, TypeScript or Python, to define all of your infrastructure as code, not just your application code, but also your infrastructure. And then on top of that, we built out level 2 constructs for the code suite tools. We have CodePipeline, we have code build and code deploy, so it was possible to use the CDK to build out an entire automation pipeline. But users were telling us that they wanted even more simplicity. They wanted things to be even easier. So we created CDK pipelines to further reduce the number of lines of code that it takes to create this full workflow, and also just to make it easier to reason about. So this is an L3 construct. It is an opinionated construct, so there's obviously going to be some trade-offs. In order to give you this level of simplicity, there were some design decisions that we kind of make for you. Some of those were in how we handle assets. We've got all of the assets for your whole project are in this one repository, and you're going to deploy that, and we're going to store that for you. We're going to put that in S3, or we're going to put your Docker images in ECR. One of the other decisions we made is that the entire deployment happens via CloudFormation. So we're not actually using code deploy as a part of the deployment for your code, right? Everything is happening with CloudFormation. So just a quick introduction to the structure of a pipeline. Obviously, it starts with your source. The idea here is that you're going to do a push to GitHub or to code commit or any of the other sources that CodePipeline is capable of ingesting, and that's going to kick off the pipeline. We're going to build your code. We're going to compile, run your unit tests. Then we're going to synthesize the stack, and we're going to output what's called a cloud assembly, which is the basic unit of deployment for a CDK project. And the next stage, update pipeline, I think this is where we have some really cool innovation. This is a self-mutating pipeline, so that if you add a new stage, let's say you add a gamma stage or add production or add some more elements to your stack, you don't have to go back and restructure your pipeline and then redeploy that pipeline manually. We'll do that for you. You just do a git push on your repository, and we'll self-mutate that pipeline to add those extra stages, and then we'll continue on with the workflow. Next thing we're going to do is we're going to publish assets. We're going to put files in S3. We're going to put Docker images in ECR, and then we're going to move into actually deploying those stages. So Rico's going to go into a more detailed demo after this, but here's just a quick screenshot of a CDK pipeline set up using Python. And as you can see, it's really not a whole lot of code. In this example, we're just configuring the source, saying, hey, go out to GitHub to look for changes to my source code. And then we're saying, here's how I want you to synthesize my application. Here, we're going to do an npm install, a pip install, and then synthesize. And like I said, Rico will go into much more detail into the actual code that's involved in his demo. CDK Pipelines is very new, so we don't have a whole lot of complete customer stories to share with you, but we are definitely getting some interest on Twitter. You can see a few screenshots here of people that are trying out CDK Pipelines and enjoying it. And we would love to hear from you. If you run into things that you don't understand, maybe you run into some issues, please interact with us on our GitHub repository, and you can submit bug reports and feature requests there. And we'd also love to hear about some of your successes as well on Twitter. And with that, I'm going to turn it over to Rico to give you a demo of CDK Pipelines.
So the nature of the demo I'm about to do means there's going to be a lot of wait time involved. And also because I have a lot of exciting stuff that I want to show you in this demo. What I did is I pre-recorded it. So I'll have a video to show, and I'm going to be narrating what's going on while I'm showing it. So let's get into it. We're going to be using GitHub to store our code for this demo. And so the first thing we need to do is make sure that CodePipeline has access to our GitHub repository. So to that end, what I'm going to do is I'm going to create a GitHub personal access token with repo access. And I'm going to be storing that in AWS Secrets Manager so that I can later use it in my infrastructure definition to give CodePipeline access to my GitHub repository. Don't worry, I already revoked the token you just saw. No need copying it out. What you're going to be doing is making a full text secrets manager secret, so not a key value secret, and you can name it whatever. I chose GitHub token. The only important thing is that you remember the name so that we use the same name later on when we're defining it. Once that's done, we can start creating our project. We usually do TypeScript demos for a CDK project, so we thought it would be fun for this webinar to do a Python demo. So we're going to be using the CDK CLI to create an empty Python project. That creates a virtual environment where we generally keep our dependencies that I need to activate. And I'm going to install the dependencies that I need for this demo. It's going to be the CDK Pipelines Library, obviously, other CDK libraries like CodePipeline and CodeBuild, an API gateway, and also at the end, I include PyTest and request for reasons that will become obvious later. And once they're all installed, I record the versions that I just installed to make sure that when I run this code later on CodeBuild, that I get the same versions of these dependencies and therefore the same behavior. When that's done, I can go into the code. So this is the project that gets created for me. And in Pipeline's webinar stack, this is where we would generally start putting our application source. So in this case, what we're going to be doing is making a very simple web service that's comprised of a Lambda function and served by API gateway. So I'm typing the Lambda function. The Lambda function is going to be very simple. It's just going to return a static web page that's going to be served by API gateway. So it just has some static body and it says, well, status code 200, which means success. This is obviously where you would put more complex business logic, but this is a demo. So if we see this, we're already satisfied. And now we're getting to defining the infrastructure that's going to create this Lambda function. So I import the AWS Lambda Construct Library. And CDK has a feature called assets, which allows me to take the code that I just wrote, that's just right there next to my infrastructure definition, and it's automatically going to pack it up, send it to S3, and create the appropriate Lambda function from that. All I need to do is reference the directory on disk. I think this is where I figured out that my Python IntelliSense wasn't working in my editor, so I switched that on. So now I'm going to create the Lambda function. Just go to create it. I pick the runtime that I plan to run this on. In this case, it's going to be Python, just a Python 3 flavor. And then I need to tell the Lambda runtime what the function is that it needs to run, the entry point. So this one is handler.handler, which is the first handler is for the file name, which was called handler.py, and then the second handler is the function def handler that's inside that file. And here I say the code comes from this asset that is in the same directory this script is, but then the subdirectory called Lambda. And that's it, right? If I were to deploy this, my Lambda would be live. Wouldn't be accessible from the internet yet. And to make that possible, we use API Gateway. This API Gateway has this nice feature called a Lambda REST API, which basically says, take this Lambda that exists and make it accessible over the internet at a URL. So I'll give it a nice description. In this case, it's a simple web service powered by AWS Lambda, and then I point it to the handler that I just defined. Now, if I create an API Gateway, it's going to get a unique identifier when it's created, and that unique identifier is going to translate into a unique URL. So beforehand, I won't know what the web address of my function is going to be. So what I'm going to be doing is I'm going to be taking the URL of the gateway, and I'll stick that into a CloudFormation output, and that'll allow me to get to the URL that was created for my Lambda earlier.
So Rico, does that allow me to take that output and like refer to it in other places in the code? Or could you talk about that a little bit? I'm curious.
Yeah, it's not in the code, right? Because by the time the code executes, there's nothing deployed yet. This is just the model of the thing that's going to get created later on. Well, what it does allow you to do is after the thing has been created, and that means later on in the pipeline, at a later point in the pipeline execution, that URL will be known and I can refer to it then.
Got it. Very cool.
Yep. All right, so at this point I can run CDK synth to see that my application synthesizes, and it does, and this is the CloudFormation template that you see when I do that. And traditionally, this is where I would run CDK deploy, and I would just directly deploy this. But I'll be faster if I create a pipeline for it. And then all I have to do in the future is just commit, and it's automatically going to go out. So let's do that now. Anything that gets deployed, the pipeline needs to be deployed as well. And anything that needs to be deployed goes into a stack first. So I make a stack to hold the pipeline that I'm going to deploy. What I'm typing now is a standard empty construct pattern. They all look the same. This is without thinking. You just type this in to make an empty construct. This doesn't do anything yet. And it's at this point that we need to start thinking. I'm going to define the pipeline. First thing I'm going to do is define artifacts. And an artifact is a code pipeline term, and it means the output of a code pipeline action and the input to the next one. You can think of actions as transforming inputs and outputs, and artifacts are labels for the input to an action and the output to an action. So in particular, in this pipeline, we'll have a source artifact, which is the source that gets retrieved from GitHub. And then there's going to be a build and synthesize step, which is going to take the source and produce the Cloud Assembly artifact, which is the output of a CDK application. So I defined two artifacts for that. And then it's time to make the actual CDK pipeline from the CDK Pipelines library. It needs to know the Cloud Assembly artifact, where the Cloud Assembly is going to be available during execution. I obviously give it a name, and I think for this demo, I pick Webinar Pipeline. Makes perfect sense. And now comes the interesting stuff, right? There are two important parts to this. Where does the code come from, and what needs to happen to the code? As source action, you can use any regular action from the CodePipeline's L2 library that already exists. So there's already a GitHub source action in there. We can just use that. That takes a number of parameters. One of them is, again, the name. So the name can just be GitHub. Then the artifact. And this is the artifact where the source is going to be stored. It's going to be source artifact, obviously. The token that CodePipeline needs that we created at the start of this demo. The CodePipeline needs to access the repository on my behalf. And then we can just tell it the name of the repository, right? And in this case, I'm using the repository that you graciously created. I could create a different one, but I just reuse that one. And the next thing that happens,
and just to clarify here, everything that you're doing is all tied to a specific region. So when you're calling that secrets manager parameter store, or the parameter from secrets manager, that's all coming from a region that you define in CDK. Is that right?
Yes. When this pipeline is deployed somewhere, provisioned somewhere, the secret needs to be there as well. I did already create the secret in a particular region. And so when I go to deploy this pipeline later on, it needs to be that same region, or I need to create the secret in a different one. The code I'm typing right now is still not, could be deployed to any region, right? It's only when I go to deploy it somewhere that it becomes important that that secret is already there. Cool. You'll see that later on. I'll do that in a bit, I think. So the next thing that needs to happen, as I said, is the source needs to be transformed into the Cloud Assembly. And that is the synth action. Needs two artifacts. The source, the input is the source artifact, and the output is the Cloud Assembly artifact. And then we run commands. So in this case, there's an install command. It's just regular shell commands. We need to install the CDK CLI, and that comes from NPM. And because this is a Python project, we also need to install the Python requirements from requirements.txt that I created beforehand. And then there's no compile step because Python doesn't really have that. And at the end, there's a synth command, which is just running CDK synth. So that's going to run the Python code and produce the Cloud Assembly.
This is based. Quick question for you.
Yeah, go ahead.
So on the install command, we are installing the CDK. Will there be like future support so we don't have to do that as a user?
It could already be, so this runs in a Docker image. You could totally be Docker images already with the CLI baked in, of course. Yeah. Cool. So basically, this is an empty pipeline already, and we can go to deploy this. And it's not going to deploy our software just yet, but it's going to set up the infrastructure to make it easier for us to iterate on this. What we need to do two more things. We need to add this stack to the top of our application in app.py so that we can CDK deploy this pipeline once. So that's what's happening here. And we need to pick an environment, as you already alluded to before when you create about the secrets. We need to pick an environment where we're going to deploy this pipeline. So you pick a region and an account. And this can be any region and account, as long as you have permissions to it, obviously. So that's my account number right there. And because I'm from Europe, I picked Germany to deploy to here. And one more thing, CDK Pipelines is in developer preview, and it depends on some pre-release features from the framework that you enable by putting that feature flag into your cdk.json. Oh yeah, one more thing. Before CDK can deploy anywhere, there need to be some resources already created in that account, and we can create those by bootstrapping. So you can call CDK bootstrap. It's a command that the CLI supports. And the CloudFormation execution policies control the permissions that CDK has to your account. You pass the ARN of a policy there. So right now I picked administrator access, but if you want a different policy, you can just configure that. Before I deploy the pipeline for the very first time, it's important that I commit and push the source that I just wrote to the Git repository. because as soon as the pipeline's been created, it's going to start running, check out the source, and it's going to self-mutate. And it better self-mutate to the right state, the state it's already in, because otherwise it might break itself. So I push first, right? I did that, and now I can go on and CDK deploy that pipeline stack. CDK CLI is going to tell me a bunch of roles and permissions it's going to create. I trust it, so I say yes. And I will do the deployment of that pipeline. And now if you go and look in your account, there it is, the pipeline. It's already running. It's already picked up the source. It's building. It's going to self-update, and there's nothing to do. So this is going to finish. And that's it. So now we have an empty pipeline. But as I said, it doesn't deploy our software yet, so let's make it deploy our software. There's one more construct we need to define, and that is called a stage. And a stage is a self-contained unit of one or more stacks that relate together that form your application. So it can be one stack, it can be multiple stacks if you broke up your application like you said. And if there are dependencies between them, the CDK Pipelines is going to figure out those dependencies and deploy those stacks in the right order so that the dependencies are respected. In this case, our stage is just going to consist of that one Pipelines webinar stack that we already defined. So I create that here. And then that has that URL output property that I created before with the address of the gateway, and I just copied that onto this object. And that's just for convenience later on. So now that we have this stage, we can add it to the pipeline. So we assign the pipeline's construct to a variable so that we can call a method on it. And the method we're going to call is add application stage. And I give it an instance of that class that I just defined, the web service stage. In this case, I call it preprod, and again, I pick an environment for this. And this could be, again, any environment. It can be an account, the same account in the same region. Could also be a different account in a different region. And that's literally all there is to it. You just put a different value here, and as long as you have permissions to it, it's going to work.
Yeah, that's my favorite feature. Absolutely my favorite feature of the entire CDK pipelines is easy ability to deploy to different regions and different accounts. It's really a game changer for anybody who's had to set that up manually in the past. This is really awesome.
Yeah, I was going to say the same thing. I think, we talk to a lot of our customers, and a lot of them will isolate their development and production environments by the AWS account. So the ability to create a pipeline that spans multiple accounts, I think is going to make a lot of people's lives a lot easier. That's really cool.
It's definitely one of the design goals when we started this project, that it should be just as easy to do the one thing as the other. Yeah.
Yeah.
Okay, one more thing. We're not going to be deploying our application using CDK deploy anymore. So I just take it out of the app.py. So we cannot do that anymore. And now I'm not doing CDK deploy to update the pipeline. I mean, I run CDK send once to make sure that I didn't make any typos and everything still compiles. But now I commit it and I push it. Right. We say at the preprod stage, git push that up. And the pipeline is going to update itself and add that new stage automatically. So it's building and updating. And there we go.
And that looks just like magic. I love that.
It is. So you may have seen it flash red for a very short while there. There's nothing to be concerned about. It means the pipeline changed while it was executing that stage. And it's automatically going to restart and run through the whole thing again. So now I'm going to the URL of the service that we just deployed, and as you can see, it works. So this is like the very basic, I got a pipeline. It deploys my software automatically every time I push, right? And this is already great. This is great for speed. But at AWS, we're all about speed, but it needs to happen safely, right? We want to do the continuous delivery, but we want to be safe while doing it. So all the rest of the things I want to talk about, I have a number more things, are all about the safety and how do we stay safe while increasing that deployment velocity. So the very first thing we could do is not deploy once, but deploy to two stages, right? And say one is for testing and the other one is for customers. And already I kind of hinted at it by calling this first stage, calling it pre-prod, right? As you can guess what I'm about to do now, I'm going to deploy a second time. I'm going to be deploying prod. And again, I just pick wherever it goes. And like you said, ideally should go to a different account or region, so the resources are isolated. In this case, I just decided for simplicity's sake that I was going to do it to the same account, but it will work just as well to a different account. And then the simplest thing I can do is I can put a manual gate in between. I can add a manual approval action and make it a human's responsibility to go and check that after something is deployed to pre-prod, that everything still works, and then they hit the button to deploy to prod. So let's see that work. I added a manual approval action. I call it promote to prod. We commit this. And then we push it out. And again, the pipeline is going to pick up the change and update itself to add the prod stage and the manual approval in between. Where is it? It's deploying assets, which is our Lambda function. There we go. So now it's been deployed. As you can see, the deploy has succeeded. This is where I would go in and check that everything still works. In this case, I just hit review and approve, and now it starts to deploy to prod. So this is like the bare minimum level of safety, right? We leave it up to the humans. Obviously, automation is better, and this is where testing comes in. So there's like two different kinds of tests we can add. And let's start off by adding unit tests. So you can test your Lambda function. You probably know how to do that. The nice thing about CDK is you can also test your infrastructure. So in this case, let's maybe say that we want to test that our AWS Lambda function is configured correctly in infrastructure level. And let's do something simple. Let's say that we check that the handler has the correct value, because that's something I could get wrong, right? So it needs to be handler.handler. Let's write a unit test to assert that. What I'm doing now is I always like to divide up my unit tests into 3 phases. I call it given, when, then, right? You don't have to do this, but I like it. Given sets up the test, then when is clearly the thing that is being tested, and under then is the code that asserts that the right thing happened. I find this makes it easy to read the tests. In this case, we're going to be adding the stack to an empty application, then synthesizing it and getting the CloudFormation template out of the stack that was just added, of our application stack. Then I'm going to get the AWS Lambda function out of that and test that the handler property has the right value. Now, obviously, this is a very simple test. For your own applications, you would do something more complicated that actually validates your business logic. But this is to show the concept. So I can run it. Let's see, run that unit test. There it goes. Everything passes. Let's see that it actually works. Very important. Let's break our code and see that the test actually catches it. And it does. We need to run this in a pipeline as well. So let's add it to our synth action. Now, as I said, Python doesn't have a build step, but I'm going to substitute running the tests for the build step. So we run pytest on my unit tests in the build. You probably know the pattern by now. I'm going to git push this up and see it go through the pipeline. And that all works. Did we actually get the safety? Let's try it out once more. I'm going to break my infrastructure once again, right? Pretend I committed a bug. So I accidentally broke something. Push that out. And if all is well, my test should now catch this, and the change should not even get out to pre-production. And it did. So that's good. Let's revert that. This is good for unit tests. Not everything can be unit tested, and you probably want to test more. If you the more complex your application gets, the more moving parts there are, and you want to test the actual moving parts. We should replace the manual approval step, right? Humans also tend to forget some things sometimes. A machine can do that a lot better, to run the same set of tests every time. I don't need to tell you why you should integ test. So we're going to be writing integration tests. I write those in Python once again. This time I'm using the request library to make an actual HTTP request. Now the question is, where should that request go, right? As I said, the API gateway has a different URL every time. Let's forget about that for now. We have that output. But for now, let's just say in the script, let's just say there's going to be an environment variable that has the address of my API gateway. I'll assume it's service URL. let's make a request to whatever's in the URL is in that environment variable, and let's assert that the status code is 200. Now, we have a test here. I want to run this in my stack, right? Sorry, in my pipeline. So first of all, that, as we talked about already, that CFN output has the URL. And by the time this test runs, which is after the deployment, that output will have the value of the actual gateway that was just created. So I need to use that object that's on that stack. It doesn't have the value right now, but it symbolically represents the object, the value at runtime. So I need to get the URL output property from the web service stage. So I need to stick that thing into a variable first so that I can access the variable that's on there. So all I did is put it in a variable. This is all the same. But now I'm not going to add a manual approval action. Instead, I'm going to add a different kind of action. And it can be any kind of action, right? Also from the CodePipeline's L2 library. But in this case, CDK Pipelines comes with a tailored action called a shell script action that's been built especially for this. I say I want to run it after the deployment has happened. And the command is going to be, and first it needs artifacts. So where is it going to get the scripts to run, right? This is Python, so I can't just take the source directly, right? The source, I can just take it and run it directly. If this was a compiled language like Java, I would probably have the build step, output an additional artifact. I would compile my jars and have the build step output a subset of those jars that are my tests to a different artifact, and those are the ones I would use. But in this case, I can just take the source directly because it's Python. And then the commands are, I need to install my requirements again because I need PyTest and requests. And then I say PyTest those intact tests that I just wrote. And now I need to get that environment variable filled. And shell script action has this one thing feature for this. It's called use outputs. I give it the environment variable that I wanted to fill. And then I ask the pipeline for the stack output, for the actual output that is represented by the URL output. And if I follow that URL output, you can see where it comes from. Ultimately, right, 2 levels assignments deep, it comes from that gateway.
That's really cool. So it sounds like what a user or customer could do is they'd want to make sure that they're creating identifiable and usable outputs for just about everything that they're doing to customize their pipeline. That's really cool. Yeah.
Yep. So in this case, we use it for that URL. You can use it for anything that's only available at runtime. Or after deploy time is what I should say. So again, commit and push. And let's see that work. It updates the pipeline. It fails, but it restarts. That's just because the pipeline changed. And it deploys. And well, the transition was a little quick there, but it succeeded. But again, let's make sure that it actually tests the thing it should be testing. So let's break it, right? Let's return a different status code, which is not a 200. And let's see that our test actually runs and protects us from the thing we don't want to happen. So it's the same thing again. And it deploys. And it fails as expected. And we can drill down into the result of that test. And then we can see that it's that, the 200 response, why it failed. Right, so no more human approval, and we can go even faster while staying safe. And there's one more thing that I want to show you, which is a feature that we use a lot at AWS as well, which is, we call it alternatively called a canary deployment or a one-box deployment. And the idea is we will only serve the new version whenever there's an update. We will only serve the new version to a subset of the users so that if a bug happens to slip by for whatever reason, it's not going to be all users that are going to be affected, but a subset of the users. And Lambda has a nice feature for that called traffic shifting, which we're going to be using, powered by CodeDeploy. And what it needs is an alias, and the alias is an indirection. So what it can do is it can point to 2 versions of the Lambda at once. It can point to the new version and to the old version at the same time. And then it can send a fraction of the traffic to the new version and a fraction of the traffic to the old section. The old version, sorry. It doesn't really matter what you call it. I called it current. And the version is the version that's going to be updated to, which is always the Lambda. And then instead of the API gateway pointing it directly to the Lambda function, I pointed to the alias of the Lambda function. So I added to the indirection, and then that's going to control, there's going to be the old or the new one. What's going to do the actual shifting is a feature of CodeDeploy called Lambda deployment groups. So that can take an alias and then shift it over time, shift it to a new version when there's a deployment. And how you do that, you can decide how to do that at what speed. There's like two big operating modes. One is called canary mode, and the other one is called linear mode. So linear mode just shifts traffic over from the old to the new regularly, like 10% more every couple of minutes. And the canary does, for the whole 10 minutes, it sends 10% to the new version and the rest of the 90% to the old version. And then if there was no trouble, no alarms or anything after that time, the deployment was good and we shift everybody over to the new version. So let's see that in action. I deploy that. And this was just, this was adding like, 5 lines of code for a pretty advanced feature, you'll agree. So again, this is really powerful. So let's see it work, right? Let's deploy a new version. Let's say we say hello from Lambda v2, right? This is going to be representative of the new version of our Lambda. Let's push that out. And then there we go. It's deploying. And now the deployment is actually going to take 10 minutes here because that's how long CodeDeploy is going to be waiting. So let's go into the events. It looks like it started. So that means the new Lambda is now available. So let's go to that endpoint and refresh it a couple times. And I expect every 1 in 10 of those refreshes, I expect it to hit the new version. Oh, there we go. That was one. See, now it's back to the old one. And there we go. It's to the new one. Right, so this is a mechanism to isolate if after all our tests, our unit tests and our integration tests, a bug or an issue happened to slip through, at least we are not impacting all of our users, but just a subset, right? So this is like blast zone reduction. But this is already by itself, if there is a problem, now what's going to happen? It's going to happen is for 10 minutes, only 10% of the users are going to have the problem, and then the deployment finishes, and then 100% of the users are going to have the problem. So what we need is a way to signal that there is a problem. So now we want to add a rollback. For example, we can use any alarm, and I happen to know that API Gateway has a metric called 5xx error, which is there was a problem with your backend. It threw an exception or something, or we didn't get a response. So I'm going to make an alarm on API Gateway's 5xx error count. I call it failure alarm, and the metric that I need to use, I know it's called 5xx error. It's in a namespace of API Gateway. The statistic that I want, I'm interested in the count, so I take the statistic sum, and I want a fairly responsive alarm, so I'm going to set it to 1 minute. The default would be 5 minutes. I want it faster than that. And I'm going to say as soon as there is only one error, this is a problem, right? One 500 error over 1 minute. This is where I remember that I also need to add the dimension to indicate the actual API gateway that I'm interested in. This one's called gateway because the node there is called gateway. And I actually made a small mistake here, and you'll see later on why I made a mistake. And now to that Lambda deployment group, if I pass that alarm, that's it, right? I told it if this thing goes into alarm, there's a problem, and you need to roll back. So again, let's deploy this. And then we'll see it work and roll back later on. So first we deploy this feature and everything goes well. Everything just passes. And now let's break it. Let's accidentally break my Lambda and commit a bug, right? So in this case, it returns a 500. Yeah, I'm not a very good programmer. I keep on breaking this program. So let's push that out. And again, it deploys. It's going to take 10 minutes because of the traffic shifting. Let's see whether it started. So it did start already. I can see that it started right there. And let's go to the address of the service, and let's refresh it a couple times again and see if I'm one of the lucky 10 that hit the now broken Lambda. Oh, there we go. I think I'm refreshing a couple more times. Yeah. So ideally, you wouldn't want to have actual, if there are no actual customers, you wouldn't hit this. So ideally, you would also have combine this with synthetic load to your service. But in this case, for the demo, we'll just do it by hand. I look into the metrics. Let's look at the alarms. Oh, yeah, I think they just went into alarm because it detected that 500 error that just got logged. And now my deployment failed. And if I look at the CloudFormation stack, it rolled back, right? Which means it restored the old version of my Lambda function, and now everything's back to normal again, and the non-broken version is deployed, and I can go in and fix it. There's one mistake that I made here. If you saw, there were two alarms, one for the pre-prod stage and one for the prod stage, and they went into alarm at the same time. That's obviously not what you want to have happen, and it is because API Gateway logs metrics by the API name, and because of the way I set it up, there are two APIs in the same account, and they're both called Gateway. So they log their metrics into the same stream, and therefore there's two alarms, but they alarm on the same metric stream. So I didn't know this when starting. If you did this for real, you would want to deploy those to different account and regions, so the metrics don't interfere, or give them a different name. Anyway, don't do what I did, but you see the general gist. So those are some pretty powerful features to keep going fast while staying safe.
Very cool. Thanks, Rico.
Yeah, no worries. If you're interested and you want to read more, here's a bunch of links. I'm not going to read them out, but you can pause the video and go here if you want to find out more about the project or this specific library to make deployments as easy as can be.
That's so cool. I certainly learned a whole lot here, and I can't wait to play with CDK pipelines more than I already have. So really excited to see how the product evolves and how we can make our customers' lives so much easier. So thank you, Rico, and thank you, Eric, for all the insight on how we developed this and some of the reasons behind it. We're going to stick around here for the next 15 minutes for a Q&A. So if you've got some burning questions for Rico, Eric, or myself, we are more than happy to answer them. And you can also reach out to us on Twitter. We'll have those handles on the screen as well. But again, thank you for attending this AWS webinar.